Okay, today's assignment. We're going to start out with a review from yesterday. These questions are very similar to yesterday's assignment, where you have to identify the angle, but notice this time the angles are not in degrees, they're in radians. How do you know they're in radians? It's not just because of that symbol pi. I mean, that's a good part of it. A lot of times when you see an angle in radians, pi will be a part of that value. But the real reason that these are in radians is because you don't see a unit next to radians, because radians are actually a unitless value. So you don't see that degree symbol, so we can tell all these are in radians. So it'll be good practice if you need to go back and review converting radians into degrees. You can go do that. Just check back to last week, and there's some instructional videos on that. But I know pi over 4 in radians is a 45-degree angle. Okay, so these are all going to be either 45 degrees, 30 degrees, or 60 degrees. And we want to draw that triangle accurately. So like pi over 4, that's a 45-degree angle. Okay, so I'm going to make this reference triangle. If you get a 60-degree angle, that's going to be a little steeper, right? 60 degrees is a little steeper than 45. It's actually 30 off of 90 degrees if you want to think about it that way. So here's our 60-degree angle, here's our 45-degree angle, and here's our 30-degree angle, about like that. Again, I just want you to spend some time being able to tell the difference between them. I don't want all your triangles to look like 45s or all of them to look like 30s. So this one's a 45-degree angle. So I'm going to just draw that 45-degree. This is that 45-degree. Here's your terminal ray. But our reference triangle, we're always going to take and drop the altitude to the x-axis, always. Okay, so here's our 45-degree angle, also pi over 4. And our reference triangle, again, look back to yesterday, we drew out those reference triangles. I like to use 1 is the side lengths for the 45. Remember, that comes from a square. And then radical 2 is the length of that diagonal. You can use Pythagorean theorem or just maybe have them memorized. And you could have actually used any ratio of sides for a 45, 45, 90. They'll all work. So what's the sign of that? Well, up at the top of my paper, I might write this out just to help remind me what the ratios are. So if it's the sine expression, that ratio is the opposite side over the hypotenuse. So from this angle, we're going to look at the opposite side and the hypotenuse and write that ratio. Okay, so this will be the first part of your assignment today. It's a review from yesterday, except these are in radians, so you have to either know or work through that conversion. Notice we have a couple of reciprocal trig expressions. Here's a cosecant, which is the reciprocal of the sine, and here's our secant, which is the reciprocal. So you're going to have to flip those fractions as you evaluate them. All right, here's the next step. It says solve the values of theta, solve for the values of theta between 0 and 90. That just means in the first quadrant, because here's 0 degrees, here's 90 degrees, here's between 0 and 90 degrees. That's our first quadrant. So on these, we don't specifically yet know what the triangle is going to look like. So you can actually just draw a generic triangle on these to help you. So I'm just going to draw a generic triangle, right? Notice terminal ray, drop that altitude to the x-axis. And so here's this angle theta that we don't know. But we do know the sine of that angle is 1/2. Well, what does a sine ratio look like? We just did it up here. A sine ratio is the opposite side over the hypotenuse, opposite hypotenuse. So here we see the values of the opposite side and the hypotenuse. So I'm going to label those sides. The opposite side is 1 and the hypotenuse is 2. Okay, so we're given that information and we're asked to find the cosine ratio. Well, what's the cosine ratio? It's the adjacent side over the hypotenuse. Okay, so I need to figure out the adjacent side over the hypotenuse, so here we go. It's this side, but notice we don't know its value. It's the adjacent side over the hypotenuse. So we do know that this answer is going to be something, some value over the hypotenuse, some number over 2. Well, what is that side? It's not given, but notice we have two sides of a right triangle, and we can use Pythagorean theorem to find the missing side. So I'm just going to say, I can call this A for now. Okay, so A squared plus B squared equals C squared. So I'll just do it right here. A squared plus B squared equals C squared. And I'm going to solve that for A. A squared plus 1 equals 4. Subtract the 1. A squared equals 3. And A is the square root of 3. Maybe as you looked at this, you already could tell, oh, that looks like a special right triangle there, because here's a leg of 1 and a hypotenuse of 2. Maybe you could have predicted that that was going to be the square root of 3, although Pythagorean theorem found that for us. These are not all special right triangles. I'll do one more for us here, but let's see. So now that we know that this side length here is radical 3, then the adjacent side over the hypotenuse is radical 3 over 2, and that's our cosine ratio for theta. All right, let's do another one here. Let's do this one here, because it's a cosecant, one of the reciprocal trig expressions here. So let's draw, it says the cosine of theta is 2/3. So I'm just going to draw a generic triangle here. And I know the cosine ratio is 2 over 3, so this is adjacent hypotenuse. So here's adjacent hypotenuse. And I need to find the cosecant function. Again, if you need to look back or look it up, the cosecant is the reciprocal of the sine expression. So if we figure out the sine and then flip that fraction, that's our cosecant. So what's the sine? The sine is opposite over hypotenuse. So we need to go opposite, which we don't know. We're going to have to find it using Pythagorean theorem. Opposite over hypotenuse. Okay, so let's see. A squared plus B squared equals C squared. A squared plus B squared equals C squared. 4 plus B squared equals 9. Subtract the 4. B squared equals 5. And B is the square root of 5. So this missing side right here is the square root of 5. All right, so a couple different options here. You could say, all right, I need to find the cosecant of theta, and that's going to be the reciprocal of the sine. So what's the sine? It's the opposite over the hypotenuse, which would be radical 5 over 3. And since the cosecant is the reciprocal, instead of writing radical 5 over 3, we're going to write 3 over radical 5 for our answer there. So you can either do it that way, or you could say, oh, since the sine is the opposite over the hypotenuse, and the cosecant is the reciprocal of that, I need to take not the opposite over the hypotenuse, but the hypotenuse over the opposite. So as we look at this triangle down here, and if we take the hypotenuse over the opposite, there's our ratio right there, 3 over radical 5. So that's your assignment for the day, guys. Stop in if you have questions, and good luck.